Good morning again. Uh, Happy to be with all of you today morning. So we shall continue our discussion on functions in today's lecture. We'll look at few examples and if you have any questions, I'll clarify them. So here is a simple example uh, which consists of this is a C program. Some average. This is a C program. What it does is let's just run this program and yeah, so GCC. Okay. And when we run this program, it takes two numbers as input and it computes the average of the two numbers and it computes the max of the two numbers. So let's say if we give the average is 0, the max is 23. And let's say if I give 23 and 6, 29. Yeah. So there is you can see the average value is wrong, 26 plus 3, 29. And yeah, it should be maybe 24 point something, 24.5. So we will see yeah, so here, so in the main, this program consists of three functions. One is the main function in which we are uh, reading the input on line number 26. On line number 28, we are printing the average. We are calling the average function. There is a function called as average. It takes two integer parameters and it computes the average of the two integers and it returns that average. So the return value is of type float, whereas the two parameters that are being passed, they are of type integer. And so there is a bug in this code, that is I should have divided it with, we are doing a division between two integers, because of that we didn't get the average right. But now it should be all right. So let's see if it is all right. Let me compile this code again. So 23, 6, now we are getting it right, 14.5. And so this is very simple example, but it summarizes what functions are all about. Every function, it takes multiple parameters and it can have a return value. And if there is no return value, we say it's of type void. And if a function is not taking any parameters, then uh, the parameter type we say it as void. Or we can even leave it with the empty parenthesis, it still works. And wherever expressions we can use, we can make a function call in any of the expressions. And a function can call another function. Like for example, the average can call the max function, the max function can call the average function. And let's see how the max function looks like. The max function takes two integers and it returns the larger of the two integers. So the return value is also of type integer here. And wherever in expressions in printf statements, we can call these functions. So this is what is called as a function call. Average, this is a function call. And in VS Code, if you kind of hover your mouse uh, over a function call, it shows the function call signature. Yeah, so so that the reason why that warning comes like this is the yeah. So I'm setting a bad example for you. So but here in C99 the standard is so the default return type for int for main is int. So if I hover the mouse over this, you can see it says int main. That's the default type. Uh, So, but we are not returning anything here, but there is a default return type also that will be present. If you don't want that return thing, then we can say void main. And if you compile, then you don't get a problem. So if you kind of make it void main. We can use int main also. A better strategy, actually the suggested strategy is to have int main explicitly. The right way to do it is to have int main explicitly and then return an integer value. Usually a return value of 0 means that the program executed successfully, and any other return value, it could indicate something to whichever the function is calling main. Okay, so this is a right way to do it. So now also you will not get any problem. Are you all with this on the simple example? Do you understand how functions work? So there are few. What are the advantages of functions? So why do we want to use functions? So there are multiple reasons. Number one, so far the code that programs that we have been writing, they are very small. Uh, because of that, we kind of did all right. But once the logic of your program becomes bigger, if you have everything in one place, then know that it's hard to read, it's hard to debug, and all those issues will be present. So, as you rightly said, so code modularity, the modularity of the code, you can divide your problem into multiple subproblems, and you can solve each of the subproblems separately by encapsulating a subproblem in a function. That is number one. There is a second reason also, that is code reusability. So like for example, we are all using printf, scanf library functions, right? Not only library functions, like for example, as a part of this course, you may have written some nice sorting function. Later on down the lane, when you're trying to solve a bigger problem, you may want to use a sort, you may want to use that sorting function. So what you can do is, in that case, instead of writing the code again, you can just take the function that you have already written and reuse the code in your new project. So code reusability is another advantage. And of course, the third case is when you are working in teams. Let's say there is a project in this course, and so a couple of you are working on the project. Then you can divide the project into multiple subproblems, and each one of you can work on different set of subproblems. And when you are trying to stitch the things together, then if you write this code in a modular fashion using functions, it becomes easy to stitch them together. Great. So now let's try to look at one more function, which is the linear congruential generator, which we have seen before. So if you see, let me recall that function. This is the original program that we have seen some time back. So this, anyway, so let it be like this. So here, this is a linear congruential generator. And so this is a random number generator. So, so just to recall what we are trying to do. So what we are trying to do is we want to generate a sequence of random numbers, and we start with x0, and x0 is the seed. So there are different ways of seeding, providing a seed. One standard way of providing the seed is by making use of this time zero function call. But there could be other ways of doing it also. And so once we have x0, what we do is we say x1 is equal to ax0 plus c. So here, this x0 we are supplying here. So this is the first random number, and x2 is equal to ax1 plus c, x3 is equal to ax2 plus c. And since we want to contain the size of these random numbers within a range, so we are doing this %m operation. And what is in this particular case, so in today's class we will see, so m is defined as 1 less than 31. What it means is you take m. So initially m is a single bit. Okay, it is so 1 means it will all be like this, zeros followed by 1. So you are taking this 1 and you are shifting this 1, this bit, this whole number to the left by 31 bits. So when you shift it by 1 bit, so let's say if you take this number and shift it by 1 bit, then what happens is the value that we get is this. So, and this is 2. If you take this one and if you shift it by 1 bit, the value of this is 2 power 1, that is 2. So similarly, if you shift it by k bits instead of this, if you shift it by k bits, the value that you get is 2 power k. And if you shift it by 31 bits, the value that you get is 2 power 31. So in general, 1 less than k. So this is nothing but 2 power, sorry. So here there is an advantage. Later on we will see that so if you want to compute 2 power k by just by multiplying 2 with 2 with 2, you are using a multiplication operator, and multiplication operator is an expensive operator. It takes multiple processor clock cycles to compute to perform a multiplication operation. But whereas what we are doing here is a simple bit shift operation, and this can be done within one clock cycle. So this is this particular way of computing 2 power k is much computationally efficient than multiplying with 2 with 2 with 2 with 2, so on for k times. All right. So this is the so this is one way of and it is when we are uh, using this linear congruential generator, the quality of this generator depends a lot on the values of A and C that we pick. And I just picked these values of A and C by looking at some manual. I forgot the source. But it is essential that we pick the right values of A and C, appropriate suitable values for A and C, so that the sequence that gets generated, it is uh, it is close to random. Kishore has this question: what are the other ways of generating random numbers? There are so many random number generators available. I will post one whole book on random number generation on the course model. So it's a very good resource. You may want to flip through it and get some ideas by looking at that resource. In the lab 5 part 3, I so there is one particular problem which suggests an alternate way of generating random numbers. So we will see that in the towards the end of today's lecture, we will see what that uh, yeah, so what that problem is. What we do, so let's say if the question is 11 less than, so what is the bit representation for 11? Let's say 11 is allocated, 11 is an integer, let's say it is allocated 4 bytes. 4 bytes means 32 bits. So this is B0 to B31. And what is the bit representation for 11? 8, 1010, 1011. Okay. Yeah, great. So 1, 1. Thank you, Kishore. 0, 1. And all these things are zeros. These are all zeros. So this is the representation of 11. This is the representation for 11. And so so if you take this one and shift it to the left by 31, so let's take the simpler case. If you take this whole thing and shift it to the left by 1 bit, then what happens is the new number that you get will be like this. So this whole 1 1 0, yeah, this will all be zeros, and and 0 will enter in here. This is how, this is shifting it by 1. So shifting a bit pattern to the left by 1 is equivalent to multiplying it by 2. It is equivalent to multiplying it by 2. And let's say if we shift it by 31 bits, then what happens is, let's say here, instead of 0, let's say if 1 is present, instead of 0, if 1 is present, then what happens? So instead of 0, if 1 is present, and the rest are all zeros, let's assume these are all zeros. So these are all zeros, 1 is present, and so when you shift it to the left by 1, this 1 falls off. And so this becomes 0, and this is what you get. Does it make sense, the shift operation? This is what is called as a left shift. This less than, it is what is called as a left shift operation. Why fall off means, because if m is present in no, we are assuming it's 32 bits. Okay, if an integer is allocated 32 bits, then what happens is, in which case that 1 will fall off. So when you take 1 and shift it to the left by 31, this is of course equivalent to 2 power 31. Yeah, approximately that's true. Left, we have to be a bit careful. Left shift by 1 means multiplying by 2, and right shift by 1 means dividing by 2. We will we will revisit it at some point in time. So this we will look into this shift operations bit more carefully later. Uh, but all we are saying is there is a question that could you please explain this shift operation? Just pay attention to what I'm saying here. This is, let's say you have an integer which is allocated 4 bytes, and the integer that is present in those 4 bytes is this 1000, all this. Uh, so we may not even consider it or treat it as a bit pattern, as a, what do I say, as a integer. It is some random bit pattern. It could mean anything. It could mean anything. So let's do one thing. So let's not treat these 32 bits as an integer. So these are some 32 bits. They are representing something. Let's not care about what those 32 bits represent. Are you with me on this one? So let's not think of those. Let's say there is a 32 bits present in a 4 byte variable. And so don't interpret it as an integer. So we are just using those 4 bytes as a storage space for 32 bits. And if you do a left shift, what happens is, so the most significant bit, this is what is called as an MSB. The MSB will fall off, whatever, be it 1 or 0, it will fall off. And the rest of these things, they will enter. Like, for example, if we have something like B31 to B0, after if you shift it by 1, then what happens is B30, the number becomes B30 to B0 followed by 0. 0 is the LSB bit. This is what is called as a least significant bit. So 0 will enter the least significant bit, and this B31 will fall off, and this whole number is still 32 bits in length. This is how it works. So let's not worry about integers. Let's just so here I'll answer your question in a subsequent class. So things get tricky if you it's a no, it's a good question only. So but I'll answer those questions in a subsequent class. But for the time being, all I want you to understand is how a shift operator works. Okay, and this is what the shift operator is, and we will look into a deeper semantics of it, and that semantics depends on the context, and we will look at it in a different session. So I hope you are all with me on the shift operation. If you're all with me on the shift operation, we will move further. Yeah, that's true. Even if bit 31 is equal to 1, then it gets only 0 will be shifted. So what you are mentioning is depending upon MSB, if LSB changes, like no, then it becomes what is called as a rotation operation. We don't have rotation operator in C. Just understand this much, how the shift operator works. Depending upon how we interpret that 32 bits, it can lead to different kinds of semantics and situations. So we will revisit them in a different session. Okay, so this is how the linear LCG, that the linear congruential generator, works. So we want to modularize this code. And we go to, yeah, let's close this one. This is so here we finished this. There is a problem here. Yeah, let's see what the problem is. So yeah, there is no problem actually. Sorry. So here there are a couple of things actually. Let me revisit some average. We will come to LCG again. One important thing I want to kind of bring at this point is what is called as a scope and lifetime of variables. So if you see the scope of this So here, if you consider the variables parameters A and B, parameters A and B, for all practical purposes, these are called as they act as local variables. What are called as local variables for uh, the function max. So A and B, these parameters, they act as local variables. They behave as local variables with respect to function max. Similarly here, if you look at the variables average A and B, so they act as local variables uh, with respect to function average. What it means is the scope of these variables A, B, and average is restricted to this function average. So the scope, this is an extremely important idea. That is the scope of a variable. The scope of the variables A, B, and average is restricted to this function uh, 11 to 18. So the average variable, it is not visible to the max function, and the variable A in the max function is not visible to the variable, no, it's to whatever the variables that are in max, they are not visible to the function average. Similarly, if you look at the main function doesn't have, if you use the variable average in the main, the compiler will complain, hey, you are using an undefined variable average. Because average is defined in, hey, I did also one mistake. Is this working? Did anyone saw the mistake here? Anyway, so let me come back to that mistake. I don't know whether it's mistake or not. Uh, so uh, yeah, I will come to that, Shashwat. So what is happening is the scope of the variables is with respect to this. The scope of the variable is with respect to this function. Uh, so there's a second idea which is called as the lifetime of the variable. Scope and lifetime, these are two important concepts. So the thing where my thought process suddenly got cut is, yeah, that's what, Lakshmanan. So just now I realized that I used the variable name average both as a function name and as a local variable. I realized it just now, and then my mind starts thinking, hey, is it possible, and why compiler didn't complain when we compile it? Uh, uh, like that. Can someone explain what's going on here? How many of you understood the problem? On line 11, we have a function by name average, and there is a variable average which is declared within that function. So what is happening? Vivek got it. Fantastic. Yeah. So good job, Vivek. So there are many interesting answers. But I think the answer is, yeah, Jatin also. So this average, the scope of this, no, this average is declared inside this function. So because of that, like when we are using average, the function average is getting masked. So the function average is getting masked. But anyway, let's not, okay, this is a super bad thing to do, but it's also, I just now realized it. And so there's a bunch of questions. Uh, I just want to make sure that all of us are with us. So, but let's see if there's this thing like average 3 comma 2. Let's see what happens. Yeah, now if I Yeah, so if you see, when I wrote average 3 comma 2, it is masked because the compiler thinks that average is a variable, but we are trying to call. So the function, the name function average, it's not visible because because the variable float is, let's compile this. Yeah. So it's a, no, it's, I think it's not about recursion. Maybe if we kind of, so now it is possible. Now you can call, but here you are not allowed to do average because return average, because it's a, yeah, it keeps looping, but I want to make a point here. Uh, uh, so we, without, like we kind of got into a bad path, but an interesting path, but I'm not sure how many students are with me. Let me recall. So if you all hold off your questions for some time, and I will, for the interest of all the students who could be a bit lost, I will take a moment and explain what's going on. So here this program is perfectly fine. What is the problem here? The problem here is, what the problem here is, uh, so there is this function, the name of the function is the average, and the variable name is also average. So so is it possible, is it allowed? First question is it allowed? So as you can see, we are able to compile the program. It is all working fine, so no problem. uh, so but what is happening here is, uh, when we are using average within this function, so this average, the reference of the variable average, it is going to this variable declaration. It is not going to the function name. Are you all with me here? So in this particular program, on line number 15, when a reference to variable average is made, so here we are making a reference to average, and here also we are making a reference to average. So when we are making a reference to the variable average, it is going to the, it is going to this particular declaration. Are you with me here? It is not going to the function name average. How many of you are with me here? Or how many of, if someone is lost here, you can message me privately if you are not. So masked means, there are two definitions. We will come to what masked means in a moment, but are you with me on this one? So if you have any problem here, you should drop me a message either here or privately. I'm fine with either ways. Could I see the pic sent by Naman? Let's see. Hey, that's what it is. Um, Okay, I think you are on the right track only. So let's not get distracted. So yeah. So this is the first thing I want you to understand. In this particular case, uh, the reference of this reference, reference 1, reference 2, they are both pointing to this declaration. So this is case 1. And we cannot call average. And so why is what is the meaning of being masked? That is, we cannot call average of 2 comma 3, and you can see so there's a problem here, because we are thinking we would like to call this function average, but it is not possible to call this function average, because this function average is blocked. The definition of the function average is blocked by this variable declaration that is there on line 13. This is what masked means. Are you with me here? Are you with me here? So if you want to think of this as a box, and in this box, so there are so there is this average, and there is one more average. Okay, so and then so there are two friends, average, outer average, and inner average, and from here you shout average, shout or call average. Okay, when you do it, what happens is the inner average responds first, and because of that, the outer average is blocked. That is because of the language rules. They have the same identifier name. That's true. So from here, when you say shout average, what happens is the shout goes to, or the shout or this call goes to the inner average. Indeed, the inner average turns out to be a variable. So Pratyaksh, I think this is a C language feature. Maybe, like in some other programming language, it might be possible for us to do the disambiguation. Okay, there is some conversation going on. So I want to see, that is what is happening, Abhinav, right? So there is nothing like recursive call. You can call a function, when you call a function by itself, uh, then it becomes a recursive. So here the use of average 2 comma 3 is not permitted, because the function average is not visible to itself. So there are three things that I want you to, I will highlight here. See, this is like a kind of googly for me also. I just checked, and I didn't plan for it. But there is a lot of interesting discussion, a lot of nice ideas are coming out. The only thing I'm concerned is some of you could be lost. But nevertheless, I will spend a couple of more minutes, and then I'll get back to the point, uh, to the to the point again. Okay. So what is the point here? So there are 3 points I would like to make. Okay. So this is the first point. The first point here is this. The first point is, so the local variable average, it is masking the function call. So the average, when we make a call, when we say average, this is going here, this is going here, and this is also referring here. And the compiler is complaining that, hey, it is a variable, you are trying to pass parameters to. Harshit, I'll answer your question not in this lecture, in some other lecture. It's a good question. So this is the first point. Okay, and this is what is called as masking. So this, what is happening here is the masking. On this point, are you with me? This is the first question. This is the first point I would like to make. If you're all with me here, this is the first point. Then I will move to the second point and try to highlight second point. Any questions here? I'll wait for a minute. If you have any questions, you can send to me separately. Okay. So this is one. Second is, so let's say if I comment out this code. So now you can see on line 17, it's not an error because because it has become a recursive call. This average call, so it gets into infinite loop. All those things are there, but this average is referring to this function call. So it is no longer masked. Okay, it is no longer masked. Yes, yeah. Yes, Vamsi. So, but then this line number 19, it's an error. You can see, this red underline. So this is an error because this is a compilation error. This is not right. We are just doing return average. It is supposed to return a floating point number, but we are doing return average. So this is a problem. So this is not the thing to do. So maybe we can do something like, but on the contrary, if we can kind of make it into return average 2, 3, then it kind of works out. Are you with me now? Yeah, this is an infinite loop. This is an infinite loop. Yeah. So I hope you kind of get some feel about the discussion that happened in the last 5-10 minutes. For some reason, if you're kind of lost for the time being, it's okay. Flush all the 5 minutes of discussion. We will, what I would like you to focus on, what I will do is I will change this code into a simpler code. Float mean. So those of you who are lost, perfectly fine. So I'm also lost for a moment, and it took me a couple of minutes to completely understand what's going on. So I will disambiguate it for you by just replacing the variable name with mean. So this is simpler thing. So no issue. So now, what is it that we are trying to, the point that I'm trying to get here is the scope and lifetime of the variable. The scope of the variable mean and the parameters a and b is within this function average. They go from line 12 to line 17. So that is the scope. So scope, this is the scope. This is the scope for variables for a, b, and me. Can we use break or go to exit a function? We cannot use break or go to. Go to you can use. Break makes sense only within an enclosing loop. Go to you can use go. We cannot use go to exit a function. Yeah. So we cannot use go to exit a function. So so this is the scope of, this is what scope means. And if you come to main, the scope of the variables a and b, the scope of the variables a and b, their scope is the whole body of the function main. Are you with me on the scope idea? This is the number one, the scope idea. Are you with me? So the second idea is what is called as a lifetime of the variable. So the lifetime of a variable, if you see this program, so in this program, if you see, so you start main and then main it calls at some point, it keeps executing At some point it calls average, and at some point it calls max with some parameters. So what happens is when we call average, when we call average, uh, when main calls average, then memory for the variables a and b will be allocated, and for mean also will be allocated, and they will be allocated in what is called as a stack. We will see what it is later, but there's a particular place where memory for the parameters and the local variable will be allocated. And after the program executes, finishes executing, not the program, after the function finishes executing, then the memory that is allocated for A, B, and mean will be released. So they are allocated in a place called as stack. They are allocated in a place called as stack. So after we return from average, the memory for the variables A, B, and mean, they are no longer there. So the lifetime of the variables A, B, and mean is the moment the function average is invoked, they get the life. And after the function average finishes, their lifetime ends. Similarly, if you look at the function main, the lifetime of the variables a and b that are present in function main, they start the moment main is called, and after the main finishes executing, their lifetime ends. So this is a clear distinction between the scope and the lifetime. So now, why are we talking about this? So we are talking about this because we are looking at this LCG, this random number generator. So we have two functions. The first function, it is a seeding function. We want to seed the random number generator. And you can see on line 12, we are declaring the variable x. X is a global variable. So this is what is called as a global variable. It's extremely important. We are introducing a new idea, that is what is called as a global variable. The scope of this global variable is this whole program. The scope of this global variable is this whole program. That is, you can use x in the function srand. You can use the variable x in the function rand. You can use the variable x in the function main, so on and so forth. And the lifetime of the variable is the whole program execution time. The moment the program starts executing, the memory allocated for x becomes active, and it will be deallocated and it becomes lifeless only after program finishes execution. So because of that, so on line 27, what we are doing is when we do a seeding of srand, so we are initializing this global variable with the seed. And even after we come out of srand, the value with which we have seeded the random number generator will still be retained. Now later on line 29, when we are doing a call to rand, so we are referring to x. This x refers to this variable x, and whatever the value of x that is present in the global variable x, that will be used to do this computation. And after this computation is done, the next value, it will be stored back in that global variable. So these are not predefined functions. Again, so I'm causing good confusion to you. So you can just, in order to distinguish them from the predefined functions, we can say my srand on my rand. So these are not predefined functions. These are our own functions. So okay. So there is a question on scope and lifetime. So let's see. Let me try to explain it again. if you look at this global variable x, okay, so this global variable x, its scope is this whole program. We can use it in this function my underscore restaurant, or we can use it in this function my underscore rand, or we can use it in the function main. We can use the variable x in any of these places. So the scope of the variable x is this whole program. Are you with me on this one? That the scope of the variable x is the whole program. First idea. I want you to understand this, that the scope of a global variable is the whole program. Number one. Number two is, how about the lifetime of the global variable x? Is it the whole program or not? The moment we give the program for execution, the memory for the global variable x is allocated, and we can use x how many hour times we want or wherever we want to use it. So the global variable x lifetime is the whole program execution time. Is the whole program execution time. So if you see, if you take the global variable x, scope, lifetime. So the scope of the whole scope is whole program. Whole program means whole program text. We are referring to the space. Scope refers to space, lifetime refers to time, space, time, okay? And then if you see lifetime, the lifetime is the whole program execution time. Whole program execution time. So are you with me on this one, the first? So now, if you focus your attention on seed, seed is a parameter. So what is the scope of seed? What is the scope of, let's say this is seed. What is the scope of seed? Can you tell me what is the scope of seed? The scope of seed is my underscore restaurant. We can use seed, only this variable seed, only between lines 15 to 17. So the scope of seed is my underscore restaurant. What is the lifetime of the variable seed? The moment my underscore restaurant function gets activated, it gets called, then it gets to life. And then the moment we come out of the my underscore restaurant function, it gets, the life of that variable seed ends. Okay. Oh, my underscore rand is not returning. Okay, so there is a bug here. But so do you understand the lifetime of the seed variable is the moment my underscore restaurant gets activated, that is called, it becomes active. And the moment we come out of it, it will be, we will come out of it. The memory for seed will be released. And so the lifetime of the variable seed ends. What do you mean by seed taking a garbage value? I don't get it. So we should return X here. Are you all with me on this example, on this code example? Does it make sense? This whole code makes sense to you? The scope, lifetime. So this idea of scope and lifetime, you have to keep asking again and again when you see something, what is its scope, what is its lifetime? Can't my underscore rand be void? Well, you can do that, but it is not a clean way of doing it, Lakshman. Because I see you want to use X, it's a global. It's let's say if you want to make this into a library, then X is not visible to that. Like for example, the srand and rand also, so they are part of a library, right? You don't see what local variables are being used in that library. Just because this whole code is present, we are using it here. It kind of we are thinking, why can't we just call ran and then use X? Okay, but it's not the right way to do it. What do you mean by my underscore rand being made global? My underscore rand, there's nothing like it's being made global. It is global. You can call my underscore rand function from anywhere here. If it is made void, yeah, if it is made void, then no, it's you have to use X. That's true-ish. Couple of you have a problem with understanding this code yet. Maybe I will, you should come to today evening tutorial session from 6 to 7:30. If you still have problem with this code, I will explain this code again in the evening session. So Rudransh, you are stuck with that average variable thing. So we will, again, so I will answer that question in the evening because, uh, yeah, can you explain where seed get its value from? We are seeding it on line 29, right? Whatever time zero returns, it's a value. That value, uh, that value is passed to this my underscore srand, and that's where we are seeding. Here, right? Can you please explain where seed gets? So this is what we are doing here. Let's say this time, yeah, so you are just providing, so let's say time underscore returns 45231. So this value will go here and X will be set to that value. No, see, X is not a local variable. You are, so Aditya has this question. So we are doing call by value. So the modification that is made to variable X on line 16 and on line 21, it is visible anywhere. It is visible anywhere. Okay. You are seeding it. You are see. Remember this how when you want to use a random number generator, you have to initialize it with a seed, and that's what we are trying to do using my underscore srand. Percent %u in printf means print unsigned number. How many of you are lost in today's lecture? Can you send me a private message? I want to see where we are at the end of today's session. You can send me a private. There are 107 students when I see this group. So I want to know how many of you are with me or not with me. So you send a separate message. Okay, I got only a couple of responses saying that they are a bit confused. So I'm assuming most of the class are with me. So we use rand and stan. We are just using this to kind of get a feel for how these things are designed and developed. Can you run the program once? So let's run it. I wanted to introduce one more idea, but yeah, time is 11:30. Maybe I should pause here. And those of you who have questions, no, I will maybe I think I will take them in the evening. Think about these things. Uh, think about these ideas. Review these ideas once. Today evening 6 to 7:30, I will be available. And if you have any problem in the concepts discussed in this session, please come to that session. Thank you.